Hello students, today we shall discuss on the topic water and nutrient management in LESA, that is low external input and sustainable agriculture. Introduction. LESA or low external input and sustainable agriculture is a system of agriculture which is based on principles and options which are ecologically sound, economically feasible, and culturally acceptable. Water and nutrient are the two most important parts in agriculture. The removal of nutrients by the erosion is the most common and extensive. The aim of water and nutrient management is to minimize nutrient and water losses for sustainable productivity. Therefore, to control losses of water and nutrients, it is advisable to go for water and nutrient management in LESA. The water and nutrient management measures fall into two categories, namely agronomic measures and mechanical measures. Agronomic measures. These practices help intercept raindrops and reduce the splash effect, improve better intake of water by the soil by improving status of nutrients and soil structure, reduce the runoff through the use of contour cultivation, mulches, close and dense crops, strip cropping and mixed cropping. Number 1. Contour farming. A simple conservation practice of farming operations, namely plowing cultivation and planting across the slope, keeping the same level as far as possible, is called contour farming. It has many beneficial effects. The ridges, furrows, and the rows of the plants placed across the slope form a continual series of miniature reservoir and barrier to the water moving over the soil surface. The barriers are small individually, but as these are large in number, their total effect is great in reducing the runoff, soil erosion, and loss of plant nutrients. Much less power is required to be exerted by men, animals, and machines. These practices save time, less wear and tear of implement if the cultivation is done on the contour instead of along the slope. Contour farming reduces runoff and prevents soil erosion, conserves nutrients and increases crop yields compared with the up and down cultivation in the major groups of soils in India, namely alluvial soils, black soils, and deep laterite soil. Number 2. Cover management to reduce runoff and nutrient loss. Legumes, being erosion resistant, provide better cover and hence better protection of land against erosion than ordinary wide row erosion crops. Cowpea, black gram, groundnut, soybean, and dhencha have been good cover crops which effectively reduce erosion. Nearness of canopy to soil surface and extent cover determine the erosion control. Number 3. Mulching. Surface mulching are used to prevent soil nutrients from the blowing and beating action of rainfall, reduce evaporation, increase infiltration, keep down weeds, improve soil structure, and also increase crop yields. Mulching is the most effective measure of soil, nutrient, and water conservation, but the non-availability of materials is due to the competition for animal fodder that poses serious limitation in its adoption, which call for strategies of in situ mulching or utilization of wheat biomass for mulching. Number 4. Conservation. Conservation tillage encompassing residue management are well-tested strategy of soil nutrients and conservation. Low-intensity tillage favors consolidation of soil and imparts erosion resistance through consolidation, structure, infiltration, distribution, and depression storage. Zero tillage with plot weeded in 30 core strips and widths cut and spread over inter-row spaces as mulch before seeding was found to be the best practice for curtailing runoff and soil loss. Number 5. Cropping systems. Cropping sequence and rotation have considerable bearing on production. For example, only tobacco cultivation resulted in maximum soil nutrient and water losses, which were reduced when a cover cum green manure crop was grown during the early monsoon before tobacco. The inclusion of a cover cum green manure crop increased the yield of tobacco and reduced the nitrogenous fertilizer dose. Number 6. Strip cropping. The importance of strip cropping in controlling runoff, erosion, and thereby maintaining the fertility of soil nutrients is universally recognized. Strip cropping, in effect, uses several good farming practices. Contour strip cropping is the growing of erosion-permitting crop in strips of suitable widths across the slopes on contour, alternating with strips of soil-protecting and erosion-resistant crops. It shortens the length of the slope, checks movement of runoff, helps deshield it, and increases the absorption of rainwater. Dense foliage of the erosion-resistant crops prevents the beating action of rain. It is better to rotate the strip planting by sowing non-resistant crop, followed by erosion-resistant crop, and vice versa with suitable weight. Different types of strip cropping are: Number 1. Field strip cropping. It is the planting of farm crops in more or less parallel strips across fairly uniform slopes but not on exact contours. Number 2. Wind strip cropping. It consists of planting tall-growing crops, namely sorghum, maize, and low-growing crops in alternately arranged straight and long but relatively narrow parallel strips laid out across the direction of the prevailing wind, regardless of the contour, for minimizing wind erosion. Number 3. Permanent or temporary buffer strip cropping. The strips are established to take care of critical, that is, steep or highly eroded slopes in fields under contour strip cropping. These strips do not form a part of the rotation practice in normal strip cropping and are generally planted with perennial legumes, grasses, or shrubs on permanent or temporary basis. Number 7. Mixed cropping. The main reasons for the lack of interest in mixed cropping in India is the small size of landholding. Indian farmers have been practicing mixed cropping for better land cover protection against beating action of the rain, soil erosion, and assurance of crop under adverse climate. This is a common practice in semi-arid regions to provide an insurance against complete failure of a given crop during adverse climatic regions. Number 8. Intercropping. The line sowing of mixed crops give rise to the practice of intercropping. Intercropping of sorghum and pigeon pea in 1:1 ratio has proved to be a sustainable system in semi-arid regions of southeastern Rajasthan. Mechanical measures. Mechanical or engineering measures are first line of defense and play an important role in controlling erosion on highly eroded situations as well as on agricultural land. Vegetative measures are adopted to support mechanical measures as a long-term strategy soil erosion control. These measures include basin listing, subsoiling, contour bunding, also called level terraces, ridge type terraces, absorptive type terraces, graded bunding and bench terracing on steep slopes. Number 1. Basin listing. It consists of making small interrupted basins along the contour with a base lister. Basin listers helps retain rainwater and is especially effective on retention of soil nutrients and water. Number 2. Subsoiling. It consists of breaking the hard and impermeable subsoil by a subsoiler to conserve more rainwater. It does not involve soil nutrients inversion and promotes greater moisture penetration into the soil, reduces both runoff and soil erosion. The subsoiler is worked through the soil at a depth of 30 to 60 cm at a spacing of 90 to 180 cm. Number 3. Contour bunding. This practice consists of making a comparatively narrow-based bund at certain intervals across the slope of the land on a level that is along the contour. It is an important measure that conserves soil nutrient and water with high infiltration and high permeability. This practice is commonly adopted on agricultural land having light texture soils, slope up to 6%, and receiving 600 mm of rainfall. The cross-section of bunds adopted in dry areas of Maharashtra, maximum in medium-heavy soils, followed by medium soils, shallow soils, and very shallow soils. The spacing between the bunds should not be exceeded 150 cm vertical drop or 67.5 meter horizontal spacing, whichever is less. Number 4. Graded bunding or channel terraces. It has been generally used in areas receiving rainfall more than 600 mm per year, irrespective of the soil texture. In clay soil, graded bunding has to be used even for areas having less than 800 mm annual rainfall. Graded bunds may be narrow-based or broad-based. A broad-based graded terrace consists of a wide low embankment constructed on the lower edge of the channel from which the soil is excavated. The channel is excavated at suitable interval on a falling contour with a suitable longitudinal grade. Broad-based terracing is recommended where farming is practiced with tractors. Number 5. Bench terracing. It consists of a series of platforms having suitable vertical drops along contours or on suitable graded lines across the general slope of the land. Terracing is usually practiced on slopes ranging from 6 to 33%. The vertical drop may vary from 60 to 180 cm depending upon the slope and soil conditions and also on the economic width required for easy cultural operations. The material excavated from the upper part of the terrace is used in filling the lower part. Bench terraces may be tabletop or sloping outward or inward with or without a slight longitudinal grade, according to the rainfall of the tract and permeability of the soil. On steeply sloping and undulating land, intensive farming can be practiced only with bench terracing. The bench terracing helps retain the soil nutrients, soil moisture, manure, fertilizers, better and facilitates the application of irrigation if available. Number 6. Grassed waterways. Grassed waterways are essentially required on agricultural land where a suitable natural drainage way is not available to drain off excess runoff safely. It is a safe disposal structure for concentrated runoff, thereby protecting the land against rills and gullies. Waterways is constructed according to a proper design and a vegetative cover is established to protect the channel section. Conclusion. Water and nutrient management in LASA are broadly classified as agronomic measures and mechanical measures. Agronomic measures are generally recommended on mildly sloping areas which range from 1 to 6% with the objective of maximizing of conservation of in situ rainfall production. They help in energy of falling raindrops, thereby reducing splash erosion, retard velocity of overland flow and enhance opportunity time to induce better intake of nutrients and water through the soil by the crop plants. Mechanical measures or engineering measures are often needed on agricultural lands to supplement agronomic measures when slope becomes steeper or velocity of runoff and discharge becomes high. These measures help in dissipating energy of flowing water by reducing of its velocity within the permissible limits, increasing the time of concentration to conserve more runoff water into the soil and soil nutrient and water erosion by reducing length or degree of slope and increasing productivity of crops. Therefore, these two measures play a vital role in water and nutrient management in Leysa. Thank you.